How to find arc length of a polar, rectangular, and parametric curve. Arc length is the length of a graph from point A to point B. Arc length is like a trail, and you are walking along it. Arc length is found using a method similar to finding area and volume. When finding area, you use infinitely smaller partitions of Riemann sums to estimate the area. And in volume, you find infinitely smaller washers and disks to find the volume of a solid. In arc length, you find infinitely smaller line segments on a curve, and you sum them to estimate the arc length. There are three main arc length formulas for the three graphs that we have learned. There is rectangular, where the length equals the integral from a to b of the square root of 1 plus the derivative squared, dx. In polar, the length equals the integral from a to b of the square root of r squared plus the derivative squared, d theta. And in parametric, the length equals the integral from a to b of the square root of dx dt squared plus dy dt squared dt. In this example problem for rectangular, we have the graph of y equals 4x cubed plus 2x squared plus 4x plus 4, and we're finding the arc length from negative 1 to 1. To do this, first we must reference the rectangular length formula, and we must find the derivative of the equation. So the equation is y equals 4x cubed plus 2x squared plus 4x plus 4, written in light blue. Then the derivative is written in a darker blue, and it is 12x squared plus 4x plus 4. So we plug that into there, and we get the square root of 1 plus the derivative squared dx. So then we must square the derivative, and we get 144x to the fourth plus 96x cubed plus 112x squared plus 32x plus 16. Plugging this all back into the equation, we get the integral from negative 1 to 1 of the square root of 144x to the fourth plus 96x cubed plus 112x squared plus 32x plus 16 plus 1 dx. Evaluating this function into your calculator using f and ing, and we're using 3 decimal accuracy, we get 166.267. For a polar example, we have the graph of y equals 5 minus 5 sine theta, and we're finding the arc length from pi over 4 to 3 pi over 2. So first we must reference the polar formula, which is the length equals the integral from a to b of the square root of r squared plus the derivative squared d theta. First you plug in your r, and so you get 5 minus 5 sine theta squared, and you find the derivative, which is negative 5 cosine theta, so negative 5 cosine theta squared, from pi over 4 to 3 pi over 2. Evaluating this in your calculator, using f and int, you get 27.730. For our third and final example, we used a parametric graph, where x equals 4 sine of 4t and y equals 4 cosine of 4t, and we were finding the arc length from 0 to t of 2 pi. When finding parametric equations, one must be careful because parametric equations will trace over each other. When the original equation called for 2 pi, but we reduced the bounds to pi over 2 because the bounds of 4 sine of 4t and 4 cosine of 4t is pi over 2, and 2 pi traces over it, and so we would get 4 times the length. So first we found dx dt, which was 16 cosine 4t. Then we found dy dt, which is negative 16 sine of 4t. Plugging this back into the equation, we integrated from 0 to pi over 2 of the square root of 16 cosine 4t squared minus 16 4t squared dt. And we end up with 25.133. This paper slide project was brought to you by Dreikosen, Patel, and Mooney.